our bodies as human species are created in a special way. Like the whole concept of food. So what we do is we eat. We take food into our bodies, and then our system, we call it our digestive system. Our system does what it does, and then the food goes out. And then we take the food out, and then we take the food into the special place called the toilet, which we created ourselves as human species, because we didn't want to go and take the food out all over everywhere because the smell is not nice. Of which other animals don't care about, like dogs and cats, they just poop everywhere. We even clean after them because we know that is not pleasant. Only because they are our domestic animals, right? Otherwise, I haven't seen anyone going around and cleaning a lion's poop because because you can't pet the lion, right? But anyway, we know that there is something unpleasant about defecation, the things that is coming out. We all love food, but we don't like taking the food out of the system, of which people are not comfortable even going to a public toilet, right? And you must know it's bad when you see a man going into a public toilet and they see a sign that reads out of order, meaning the toilet is not functioning properly, but yet they feel they need to open and check, Hori, can I handle the out of function or not? Something like that is what I mean. And I'm talking about if a toilet functions properly, our expectations is I need to go inside there, do what I do, and then I flush, and then whatever I did, it goes out, and then it goes into a storage system. That's when a function is functioning properly. But then if it's out of order, when I flush and I see what was supposed to be the output now coming into the room and then it floods on the toilet, now it's no longer functioning very well. I won't feel the need to wanna go into the toilet. I won't feel the need to wanna be an input going inside the toilet. Do you see where I'm going with this? I'm talking about function. So when when the toilet is working properly, that's when it's functioning properly. When it's out of order, it's no longer a function. It doesn't function properly. I just explained to you the definition of a function in a fun way. I just wanted to use this example because I'm trying to state that if you understand something, you have to be able to explain it. That's a fun way to explain a function. This is just an intro. I want us to go into in-depth talking about how functions work in mathematics. Why did I choose this topic today? Because I've realized that majority of students from grade 10 to grade 12, there's that question which is the heart of a question paper. It's normally question 5 or question 6 or question 4, where you are given a graph of mixed fractions. And from those graph of mixed fractions, you have to answer questions. And how can you answer questions while you don't understand what a function is? Because most of us, the way a function is presented to us, one moment we'll be learning about a Cartesian plane, the next moment you are introduced to the straight line or a linear function, y is equals to mx plus c. The next thing they introduce a parabola, and then they say f of x, sometimes h of x, sometimes g of x, and they say this is a function. And you try to ask yourself, what is really this function? Before you know it, they're like domain, range, and then marks now are fading away because students don't like this question. Or even if it's not even about them liking it or not, like students perform poor in a topic like this. And that is the heart of the mathematics. That's why you're supposed to brag, or I understand what I was doing in question 1 when I was solving for X. Because the way the question paper is drafted, the first question, by the time you are preparing for your exam, most people know how to answer the first question. The second question is arithmetic sequence. You can play around with your arithmetic sequence, and then your third question could still be arithmetic as well. But when you get to the fourth one, up until the last, you'll find that it's a 0, 0, 0, 0, and then you end up getting a lower mark because you failed to understand what a function was. Now, I want you to look at it in a different way. Let me open this. This one I'm opening it for myself. I want you to look at it in a different way. I want us to talk, first of all, the definition of a function. When you read it from sources like Google or whatever, it will tell you about inputs, output, input, output. So this is how it works. I want it to make sense once and for all. So you see, this is how a system works. This is a function. This is a function. This is, you have an input. The input goes into the machine. The machine does its magic. After the machine does its magic, the output comes as an output. We expect the output to be always the same if the function is correct. Every time we put an input, we expect the output to be always the same. So now, let's use our body as an example, our digestive system. We put in food through our mouth into our stomach, which is our system. Our system works its magic, and then the food comes out as an output, which is poop. And if you eat an apple, the machine is not going to disappoint. It's going to give you the same poop. Might consist of different ingredients, but it will be poop. You eat a burger, the machine does its own thing. The output is poop. You drink water, the machine does its own thing. The output is urine. You drink cold drink, the machine does its own thing. The output is urine. So input, when the machine does its own thing, we always expect a certain output that we know it's going to be that. If one moment I eat a burger and then the output is something different, unusual, and then I would go to a doctor because I'm not functioning properly because the machine is faulty. That's when the function is not functioning properly. So that's what a function is, guys. So mathematically, we then say a function is represented by inputs and outputs, right? So the inputs, that's when the inputs, we use X to donate the inputs. And then for the outputs, we use Y to donate an output. So input X, system does its own thing, output Y, the results from the input, you see. And then I'm going to put this here. You've seen this before. F of X is equals to 2X plus 3, for instance. You've seen something like this. F of X is equals to 2X plus 3. And then Y, we all know, since we're talking about function anyway, we all know that Y is relatable to F of X. So Y and F of X are the same thing. So our output is function of X. So the output is Y. Y can be represented by F of X as well. The input is X. So if the input of this function happens to be 2, that's the input. If the input of this function is 2, now where there's X, which is the input, I would have to put 2, such that I would have F of 2 is equals to 2 plus 3, which means the output will be F of 2 is going to give me 2 times 2 is 4 plus 3 is 7. So the output is 7. So I know every time I input 2 on the machine, which is the equation now, the output will always be what I'm expecting. That's another way to look at it. Now, using our body, our digestive system, input being the food, output being whatever, it might be silly. Let's try to take it to some example that we can all relate to. I'm going to make a perfect example. The South African taxi system, right? I'm familiar with the taxis from around Pretoria. So the way it works, it's like if you are in Mamelodi at the taxi rank, you have taxis that goes to different roads. There are taxis that goes to mainland. There are taxis that goes to Sunnyside. There are taxis that goes to Arcadia or wherever it can be. But all in all, you only take a taxi to which goes to where you are going to. So if you go into a taxi, the taxi is going to CBD. Regardless what route the driver is supposed to take, they will end up in CBD because that's the final destination. So the function is the input in this scenario is the people who are going to the inside the taxi. They are the input. Their goal is to reach CBD. Whatever happens, the driver has to make sure whatever routes he takes to avoid traffic or whatsoever, at the end of the day, he must reach CBD. If he doesn't reach CBD and end up going to a different destination, and then we say the function is not functioning, that's the same way when the toilet is out of order. Imagine a taxi is written Pretoria CBD, and then the next thing you wake up in mainland and you're supposed to be going to school or work, and then Luana, you're gonna strike like, this function is not working properly. So that's not a function anymore. You see where the whole function concept goes. So this is how it works. So mathematically, the input who are going into the machine which is the taxi that must take them to their final destination, which is CBD. So the input is the people going into the taxi. The taxi does its magic, traveling all the roads until you get to CBD, which is the output. And it makes sense because when you are going into the taxi, you are going in is the input. When you get to your destination, you are going out. It is the output of the function, guys. So that's what we mean about the whole concept of input and output when we try to define a function. Let me think of another example. However, I don't really blame the students for not understanding questions like this because we also play a role as educators, the way we present functions to them. You can't go ahead and solve something which you don't understand what you're doing. But otherwise, we know that a lot of people, that's how they approach mathematics. We have a lot of teachers who went and studied education and they are teaching mathematics probably in high school somewhere there, but even them themselves don't understand probably how function works. If you can ask them what is a function, someone wouldn't really explain the whole definition of how it works. And I'm saying this because you can memorize a theorem in mathematics without even understanding what the theorem is about or what the concept of the theorem is about, just because you want to get marks. So they'll tell you that this theorem will come out on an exam. And then you can literally just look at the theorem, memorize exactly how it is, bar for bar. You go to the exam and then you put it as it is. That's like approaching mathematics like a history, like a historical subject. But anyway, all I'm saying is there's a lot of people who can get 100% on a question paper, but without understanding really what they are doing. And I'm saying this because sometimes that's the approach we use. But there are situations where you should approach such approach. I'll give you an example. You would get a student who's 40 years old studying statistics at UNISA, and statistics is the only subject in their qualification that they have to do that relates to mathematics, and they have no clue what statistics is about. And then when you try to offer them lessons, on the first lesson, they'll be like, "Yo, mtanam, I don't have time for this. I have a husband, I have children, I have to cook, I have to work. Time to can sit and understand this, hey, it's not there." And then you have to come up with a concept of making them understand how to answer the question only. So bar for bar, statistics comes in the form of weight problems in most cases. You're like, okay, sharp, when you see this paragraph, you must know this paragraph relates to this question, to this equation. And when you see this equation, you just punch it like this on the calculator and then you'll get the answer. And then you're like, okay, here, try it. And then they try it, they punch it, and the answer come out. And they're like, yeah, I understand. But not that they understand. They just know how to get an answer. But there is a background mathematics to it as to how things goes like that. So at the end of the day, the best way to approach things is to learn them properly. But then there is no time to learn things properly because even at school, a teacher has to complete the syllabus in a certain period, and they have to report to the principal every now and then that I've covered this part, I've covered this part, I've covered this part. And by then students are not understanding what's going on. By the moment you get to the third term, everyone is just lost because they were lost in the beginning, and then students end up doing bad. But mostly because we could have failed to introduce how a function is, or what a function is, in a proper scenario of which they can understand. Look, man, if you go into a building, you go inside an elevator, you are going to level 4. You press 4 on the elevator. You expect the elevator to take you to level 4. Every time you press 4 on the elevator, it will always take you to level 4. If you press 5 on an elevator, it will always take you to level 5. If you press 3 on an elevator and somehow it takes you to level 5, you might walk out and use the stairs to get to the floor that you want to get to, because the elevator is not functioning. It is out of function. And then they will put a sign outside that states out of order. That's what a function is. So in mathematics now, that's when we have linear function of a straight line. If you use this Texas to Mamelodi, there's a part where taxis meet, and then you choose your road. And then by a straight line, Samaya. And then what's Amaya? But at the end of the day, the whole concept is the function is the route of the taxi. It's going where it's going. If you get to a wrong one, then you have lost the function. That's a non-function now. So we can, I had an example here. Let me look for the example. So this is the example that I wanted to show. Here we have a function. Here we have things that are not functioning properly. Remember, in terms of our function, we have our input. We have our input and we have our output here. We call this a one-to-one function, and the input is represented by X and the output is represented by Y. Now, input is our taxi. When you go into the input A, which is Mamelodi, your final destination will be Y, which will be Pretoria CBD. When your input, you are taking a taxi from Atteridgeville, and your output is you are going to Hatfield, you will reach your destination at Hatfield. When you take your taxi in a different area, you will always have the outcome of where you want to go. So from 1 to 1, hence we say this is a one-to-one function. But two people can go to the same place. Like two people can both take the taxi to Mamelodi, and you find that both the people are going to CBD, and then they'll always reach that destination together. And one person can take and go to a place of their own, but it has to be under the same route of the taxi, you see. So we say it's many to one, but at the end of the day, it all must satisfy X, Y, and Z, because X, Y, and Z is the route that the taxi is passing when it's going to CBD. It's gonna go to Silverton. Some are going to Silverton, some are going to Arcadia, but the final destination is CBD. So that's how a function is. So look at this. For the non-function, you can't go into one taxi and you expect to be at CBD and at Hatfield at the same time. It doesn't make sense. That's not a function anymore. It's no longer functioning. You can't get into a taxi from Mamelodi and you expect that taxi to take you to CBD and Hatfield at the same time. You rather go to one place and then go to the other place as well. So we say this is a one-to-many scenario, which is not a function. And also, here, look at this. One person wants to go there and there at the same time. This other person wants to go there and there at the same time. That taxi you will fight, unless it's a special. If it's a special, you can arrange it like that. But even if it's a special, the taxi driver has to go route by route and collect different people depending on how the road goes. So we say this one is many to many, many to many. And if it is a special, people might not understand what I mean by special. So a special is people who are working at the mall and they stay in the hood. Um, Around 9 o'clock, 10 o'clock, when the shop closes, there are no taxis anymore at the taxi rank. So they created their own function, which collects them mall to mall for taking them home. So that's the function for the employees only who are employed at the malls. If you, as a person, try to stop a taxi, which is a special for people who are working, they're not going to stop for you because they know we only take people at the mall. So for you, it's not a function anymore because it's not functioning in your expectations. That's what a function is. So I don't know why we always push around the function and how to understand how it goes. But then now, from the functions, then we have a domain, then we have a range. Then we present this function graphically. When we present this function graphically, that's when now we introduce the Cartesian plane. And when we introduce the Cartesian plane, mathematically, we then say, so here's my function. F of x is equals to 2x plus 3. And then we say I can represent this function graphically. And then if I represent the function graphically, that's when we have the Cartesian plane where we have the y-axis. Remember, the y-axis is the same as f of x. So we have the f of x axis and we have the x axis. That's how we now present it in the Cartesian plane. And then from here, I can take this information and I put it onto the graph. And when I take this information and I put it onto the graph, that's what we do, the whole thing of saying, let x to be 0 to get the y-intercept, and you let y to be 0 to get the x-intercept. I'm not really deep into this, but at the end of the day, imaginary, you'll end up having your line going like this or like that, whatever value you may get as an outcome of this. And then you now hear stories like, what is the domain and what is the range of this function? This is what I want us to talk about on our next video. So this video was just to introduce the definition of a function so we understand exactly what a function is. So by the moment we relate it to this, it's going to make perfect sense. By the end of the series of the videos for explaining a function, we're going to do all these questions that I've been displaying here. So now, join me on the next video. Don't forget to subscribe and follow us and set a reminder button because sooner we'll be going live every now and then because it's now the exam period. So if you want to be notified whenever we are live, hit the reminder button and follow us in all our social media platforms. And do contact us to inquire about our private lessons because we offer private lessons at a very reasonable amount or price. Yeah, amount price. But yeah, here are the contacts here. Please do contact us. I'm Mr. Maimane. This is Simplified RSA, and we are the guys who makes it looks easy every day, every day. Meaning we are the #1 institution in the world. But that's a story for another day.